Good morning, everybody, and welcome to today's webinar. My name is Cheryl Jennison DeProsa, and I'm joined by my friend and colleague, Mr. Gino Sigismondi. And today we're going to be discussing a question that we get a lot, which is, how do I choose a wireless system? There are a lot of factors that go into it, and we're going to kind of delve into those and maybe give you a roadmap on how you can select your next wireless system. But before all of that, just a few items of housekeeping. This webinar is being recorded and will be available for on-demand viewing. It'll probably take about a week or two after today for you to be able to see it, but when it is ready, you will be able to find it at shure.com/training. There is all sorts of great webinars, past webinars archived there, so please feel free to go there and peruse. Lots of great webinars across lots of different topics, so just a lot of great learning to be had at shure.com/training. And then second of all, as we go through today, if you have any questions, please feel free to type those into the question pane. If you don't see the question pane, look for a little toolbar somewhere in probably the upper right-hand corner of your screen. On that toolbar, you'll see an orange box with a white arrow on it. Click on that, and that should maximize that question pane. Enter any questions that you have. We will answer as many of those at the end of the webinar, so please be patient, and we will get to your questions at the end of the session. So that wraps up all the housekeeping. Let's get into the learning. Take it away, Gino.
Thanks, Cheryl, and good morning to everyone. Thanks for being here. I think this title is pretty self-explanatory, so I'm just going to launch right into it here. This is obviously a question that we get a lot, otherwise we wouldn't be doing a webinar on this topic, but over here in Shure Applications Engineering, a lot of the phone calls we get are from people who just want to figure out which wireless system they should buy. And wireless microphone systems are one of those things where you do get what you pay for. There actually are some good reasons to pay more for a wireless microphone system, but you don't always necessarily need to. I mean, I guess the flip side of that would be some people just want to buy the best because they want the best, but depending on what it is you're doing, it may not be necessary to spend $2,000 on a wireless microphone system. But let's start with three things you must know. And how we're going to start the topic here is we're going to try and, I guess, do a little bit of myth busting about what are the really important factors that separate wireless microphone systems and which are the things that are maybe important for certain applications but really aren't the critical factors. So let's start with the critical ones first. Obviously, what are you doing? We have lots and lots of different wireless microphone systems now, and whether you're choosing one for your fitness studio versus going out on a major concert tour versus a Broadway-style play, those are all very different applications. So, of course, you need to understand what it is you're going to be using the microphone for. Where are you? This is important based on the frequencies that professional wireless microphone systems operate in. And we're going to talk a lot more about what that is and what that means in a little bit here. But when you're choosing a wireless microphone system, it is very important to understand that your actual location, not only in the world, but in your country, what city you're in, is actually relevant. And this one is highlighted in red because this is really the big one. How many wireless microphones do you need to use in the same room at the same time? This is a question that most people don't know to ask, and that's why we make such a big deal out of pointing out, because it really is the biggest differentiator between as you move up between an entry-level wireless microphone system to more of the mid-tier offerings to something that is a very high-end system. This is the major factor. So what that means is if you are, I'll choose a high school theater program. Often there's some budget constraints there. You don't have all the money in the world to spend on a wireless microphone system. But you're trying to do, a pretty big production. A lot of these high schools are doing, musicals that are, an adaptation of a Broadway musical, that they're going to do, and they want it to sound like a Broadway musical. And the way to do that is to give every actor with a speaking line a wireless microphone, which could be sometimes 30, 40 wireless microphone systems. But then you say, yeah, but we're on a budget. We can't afford a lot. So what's the cheapest wireless microphone system out there? It's like, well, that right there is not going to work, right? An entry-level wireless microphone system can handle, 6, 7, 8 channels of wireless simultaneously, maybe perfectly fine for, a local gigging band that, just maybe the guitar players and the singer want to be wireless, totally fine. But when you're trying to do a large scale production that could have, you know, dozens of channels of wireless, you have to go higher end. You can't do it on the cheap side. So that's why knowing that is really an important thing to do. And as it says, you have to include existing systems as well. You have to know how many if you already have some wireless, you need to know what those are, what frequencies those operate on, and include those in the total calculation. And the final bit on this, not to keep beating it into the ground here, but the final thing to understand too is that you can't start with the less expensive option today and then grow into a larger system and expect to keep using those. In other words, you always have to think about the lowest common denominator. That is, if you say, well, we only need 4 wireless mics today, but eventually we want to have like 20, then you need to start with the system that is the end goal, right? Or else if you buy the entry-level system that 4 is no problem, by the time you build up to 20, you're really probably not going to be able to use those original entry-level systems. That's always going to be kind of the limiting factor in the total that you can do. So always think about, not only how many need to do's today, how many existing systems you have, but where you expect to be in the future if you're going to be growing into a larger wireless mic system.
And another important thing I want to point out with the how many and including existing systems, this also includes if you're using onstage monitoring. Not just wireless microphones and wireless instrument systems, but wireless monitoring systems. Sometimes you kind of separate those and you don't think of them in the same way, but that is also needs to be included in that total number.
Yeah, that's a great point. And since we're on that path, if you're a larger scale production and you have wireless intercom for your crew, that factors in as well. A lot of those systems operate in the same frequency bands. But one thing you're starting to see from a lot of manufacturers, particularly in intercom systems, made me think of this, is branching out into other alternative frequency bands besides the UHF television band that we traditionally have tried to operate all of this stuff in, and we'll see why that's happening in a couple of slides here. So these are the most important things you need to know when choosing a wireless microphone system. Now there's a whole list here of secondary considerations, and these are things that may or may not be important depending on what it is you're doing, and we'll kind of go through some of these in a little bit more detail as we go through the rest of the webinar here. But things like rack mounting, right? That may be important if you want to rack mount your systems, but if you don't care or don't have an equipment rack, then it's not so important. Remote antennas may be important depending on whether or not you are going to be putting your wireless mic systems in a closet in another room. Then remote antennas might actually be a big deal to you. Metal. This is the whole metal versus plastic, particularly on the transmitter thing. This can be a very important thing to some people. I will say that most decent pro audio manufacturers, even on their plastic components, are made of a very rugged plastic. So it's often a bit of a misconception that plastic equals cheap. It certainly is more affordable, but I wouldn't necessarily stay away from a plastic transmitter just because you're afraid it's not going to be as durable. Again, all depends on your application, and we'll talk about the rest of these things as we go through here: the digital versus analog on a wireless mic system, range, networking, encryption, rechargeability, etc. Taking a step back for a minute, let's make sure we define clearly what a wireless system is. And the reason it's called a system, wireless microphone system, is because it includes a series of components, and you need all of these components in order to have an operating system. This may be seem a bit basic for some of you on the webinar, but we do want to make sure that everybody clearly understands this. So you have to have, of course, the actual microphone itself, or input source, whatever that happens to be, if it's a guitar wireless or something like that. The transmitter, which takes the audio signal from that microphone and converts it to a radio signal. And the receiver, which picks up the radio signal and converts it back into an audio signal. If you don't have all 3 of those components, then you do not have a functioning system. It's also worth pointing out that in most wireless microphone systems, I can't say all anymore, but most of the traditional ones that we'll be talking about here today, it's a one-to-one relationship between the transmitter and the receiver. That is, for every wireless microphone that is connected to a transmitter, you have to have a receiver dedicated to that transmitter. So if you want to have 10 wireless microphones, you need 10 receivers, right? You can't have a receiver picking up multiple transmitters at the same time. And that's because each system operates on a unique frequency. And therefore, the receiver has to be tuned into the frequency of that transmitter. If you wanted to have multiple transmitters all talking to the same receiver, you'd have to have that receiver would have to be, well, all those transmitters would have to be tuned to the same frequency of that receiver. And when you have multiple transmitters tuned to the same frequency, they interfere with one another. The analogy we use is if you listen to the radio in your car, you might be listening to your local rock station or whatever it is you like, that could be broadcasting at 93.1 megahertz, right? And that's the only then transmitter that for that FM station that can operate in that city, because if there was another one and you tuned to your car radio to that transmitter, which station would it listen to? They'd be interfering with one another. So you can almost think of your wireless microphone system as a mini FM radio station. That's kind of like what it is. So each one has its own frequency, and you could have as many receivers as you want listening to the same transmitter. That's not usually practical or needed in a wireless mic application, but to come back to the wireless monitoring systems, that's very common, where you have one transmitter putting a monitor mix out there, and if every performer wants to listen to that same monitor mix, they can all have a receiver tuned to the same frequency. But in wireless mic land, it's generally this one-to-one relationship. So going through the components again, the first thing you really need to do is decide what kind of microphone you want. And again, that's largely based on what your application is, whether it's, a presentation type application or teaching, or like I said earlier, a fitness instructor, or if it's, again, singing for a rock band or a guitar player, what is it that you're doing? And that will drive the microphone choice, first of all. Lavalier mics are sort of the go-to choice for public speaking type engagements and theatrical applications because they're small and they're hands-free, and everybody really likes that. It's important to understand that the original application for lavalier microphones was more in the broadcast realm. You see them used in television interviews a lot, etc. And the reason they work well for that is because you don't have to worry about feedback. As soon as you get into a live sound situation where you're reinforcing that microphone, you can oftentimes run into feedback scenarios because the microphone is relatively far from the sound source, which is, of course, the talker's mouth. And the easiest way to avoid feedback is to get the microphone closer to your mouth, right? You can't really do that with a lavalier microphone. And plus, you can get more effects as the person's head moves back and forth. They're not always on axis with the microphone directly. That's why we like head-worn microphones a lot for live sound reinforcement. Again, even if it's a speaking application, because the head-worn mic, as shown in the lower left-hand picture there, now the microphone is really close to your mouth. It couldn't get much closer, and the positioning is much more consistent as well. So you've got that going for you. So for a lot of speaking applications, we really like head-worn mics. Of course, for the fitness instructors, that's what you use too. There are many different models available there. The one shown in the picture is really more of the presentation type or maybe theatrical. I don't know that I'd use that for a fitness instructor, but we do have headset mics that are specifically designed for fitness applications as well, that are a little more durable, a little more waterproof. So a couple of different options there. Handheld kind of speaks for itself. You hold it in your hand. That's the transmitter, and the microphone itself are kind of one unit. It looks like one thing, but that actually is both of them together. And then, of course, the musical instrument application, which could be a guitar connected directly to a body pack transmitter, could be a microphone that's clipped onto the bell of a horn or something like that, again, plugged into a body pack transmitter. Those are all considered instrument applications. Transmitters, of course, the transmitter's job is to take that audio signal and convert it to a radio signal. Again, in the handheld, it's that all one-piece design with the microphone itself, and then body packs, of course, can take lavalier mics, headset mics, instrument mics, direct instruments if it's an electric guitar or a bass or something like that. All of those things get used with body pack transmitters. The one type that's kind of not shown is what's called a plug-on transmitter. You sometimes see these used in more in broadcast applications where you have a specific handheld type mic, wired handheld mic that you're using for broadcast interviews, and you'd like it to be wireless. The plug-on transmitter is a little, usually brick or square-shaped thing that plugs onto the base of a wired microphone and makes it into a wireless microphone. You don't really see those used in performance very much, but they do get used in broadcast applications. Receivers also come in many different styles. There's, of course, the kind of something you see typically more on just the entry level side of things is a tabletop receiver, as shown here. This particular one has permanently attached antennas as well, so kind of a little bit more entry level. Rack mount receivers, which almost always have detachable antennas. Something, again, we'll talk about why you might want that a little bit later, but you can get rack mount receivers, portable receivers, which are battery powered and often intended to be mounted on cameras, used, again, more in broadcast applications like that, and multi-channel receivers, which are really just a rack mounted receiver. Actually, they don't necessarily even need to be rack mounted, but a receiver chassis that is housing multiple receivers in it. So what's shown here is what's called a quad receiver, which means there are 4 receivers built into a single 19-inch rack unit. The confusion here is sometimes, when we talked about having, one receiver picking up multiple transmitters and why that doesn't work, sometimes people will see this and think, well, how come this one can pick up, 4 wireless microphones? Well, it's still 4 receivers. They're just all put together in one box. So there's dual, there's quad, but again, it's still multiple receivers, just again all put together like that. Oh, and of course, a very kind of application-specific receiver, which would be the guitar pedal receiver, which is available from some manufacturers. And the idea here is it can live on your guitar pedal board next to all of your other effects pedals and whatever, and make it wireless that way. So a little bit getting pretty application-specific there. Let's talk a little bit about the frequencies where wireless microphones operate. Now, we're using the United States as an example here, but there are several different frequency ranges that are, fairly common in most countries. There might be some specific restrictions or regulations that don't make all of these frequency bands available to everyone, but in general, you can find wireless microphones operating in these different bands. The bulk of them operate in that big blue block in the middle, which is the UHF television band, which, again, this is in the U.S. Today extends from 470 to 698 megahertz, but as we'll see on the next slide, that's shrinking. In some other countries, it goes a little bit higher, or maybe it's a little bit less. It can vary slightly, but that's what's generally regarded as the UHF TV band, generally where most wireless microphone systems operate, because, as you can visually see here, it's the biggest block on the chart. Even with the shrinking that it's experiencing, it's still the biggest block on the chart, and that's why we continue to make available many wireless microphone systems there. VHF, which is kind of shown off to the left, 174 to 216 megahertz in the U.S., has always been available to wireless microphones, and 20 years ago was the primary band where wireless microphones were used professionally. Everyone kind of migrated to UHF, but now that UHF is shrinking, suddenly VHF doesn't look so bad anymore. So you're starting to see some options there. The other ones I'll call attention to are kind of more to the right side. You have the 900 megahertz industrial, scientific, and medical band, which is 902 to 928 megahertz. That is an unlicensed band, and also 2.4 gigahertz, another unlicensed band. The neat thing about 2.4 gigahertz is it is the only globally harmonized band. So if you want to buy one wireless mic system that you can use pretty much all over the world without worrying about any local regulatory issues or anything like that, 2.4 is it. What's the downside? Well, it's the same band that's used by Wi-Fi and Bluetooth and all kinds of consumer products, so it's a very congested band. The reason we like UHF, to keep coming back to that, is it's very predictable, right? When you're dealing with television channels in a local market, there's either a TV channel on the air or there isn't, and as long as you're operating on a channel that is not occupied by a TV broadcast, that's going to be a good frequency. When you get into the unlicensed bands, things get a little bit hairier. All parts of the world are now going through a spectrum crunch. The U.S. seems to be in kind of one of the worst spots at the time compared to some other countries, but everybody's losing some of the UHF television band for various reasons. In the U.S., we've been going through what's called the incentive auction, which affects the 600 megahertz band. Not quite all of it, but a good chunk of it. Essentially, everything above 616 megahertz within the next 2 years or so is going to be unavailable to professional wireless microphone users. We have an archived webinar on this topic for those of you who'd like to really delve deeply into it to get all the ins and outs of it. There's also a page on their Shure website called the Incentive Auction Resource page, which has a lot of good information on that. But again, to kind of keep it short, we'll just say that we're in the middle of a rolling transition as T-Mobile and the other auction winners of this band start to roll out their new systems. The long and short of it for U.S. customers is if you already have wireless microphones operating in the 600 megahertz band, you're going to need to get out of there, probably sooner rather than later. We are currently running a rebate to assist customers with that transition and buying a new wireless where you can send in your old 600 megahertz wireless and get a pretty good rebate towards the purchase of a new Shure wireless. So that you do have that to look forward to.
And just a note on that, if you were previously aware of that, they have extended the deadline on that rebate to October 31st. So if you were planning on taking advantage of the rebate, but you were concerned about getting it done in time, I believe it was originally supposed to end in April, you now have until the end of October. And it is based on what system you buy. So technically, if you really wanted to go all out, you could purchase the most expensive system and trade in an entry-level system and get the maximum rebate. So it's a really good deal. And if you visit our website at shure.com, you can find more information about the rebate.
And as I mentioned, this isn't, a situation that's unique to the United States. If we take a look at some other parts of the world, and the European Union is currently transitioning out of the 694 to 790 megahertz range, which has been auctioned just like in the U.S. for LTE and 4G purposes. This is a staggered rollout. Again, going through the next 2 years or so is when this is going to happen. Germany is probably going to be one of the first ones to transition there. The European Union, though, has suggested or recommended that in light of this transition, that the remaining spectrum, 470 to 694, remain stable until 2030. That's kind of a nice thing, actually.
That's really nice.
Because one of the questions we get in the U.S. a lot is, okay, well, they auctioned off 700 megahertz, so we bought new wireless because of that. Now they auctioned off 600 megahertz, so we bought new wireless because of that. What kind of guarantees do we have that they're not going to auction off more? How much further is it going to go down? And try to be as reassuring as we can. I mean, it seems pretty unlikely that since we haven't even gotten through this transition yet, that there's suddenly going to be another one coming anytime soon. But there's certainly no guarantees either. Like I always have to preface to people that the FCC can do whatever it is within their power to do. So, could they auction off more of the UHF band in the U.S.? They could. There's no recommendations from the government here that they not do it like you're seeing for the European Union. But again, it's unlikely that would happen. In the UK, they're currently transitioning wireless mic users out of the 703 to 790 megahertz band. Again, also auctioned to mobile services, looking to complete by May of 2020. There is a government funding program there to compensate affected users that should kick in mid-2019. Check in with your local Shure branch or government regulatory agency to get more information on that.
And I just want to highlight, I think seeing these numbers and how different countries are dealing with spectrum, it's important to know that every country has different rules about available spectrum and what you can use. So I get a lot of questions sometimes from people from other countries saying, well, can I purchase my system in the U.S.? No, purchase it in the country that you're in because those dealers are selling products that are in the usable spectrum in your country. So it's really important to purchase directly from your country from someone that is aware of what's going on with available spectrum.
Yeah, that's a great point. Since we're talking about international wireless, as I mentioned, besides 2.4, there is no globally harmonized band, especially for professional applications, which 2.4 is really not. So you do either want to check with the local agencies, and I'll show you guys a link later on where you can see how you can find out what some of those agencies are, at least in Europe, or again, just work with the local Shure dealer, Shure distributor. The last country we'll highlight here is Japan, which went through, again, a pretty significant reallocation here. In Japan, there was a band called the A band, 770 to 806 megahertz, that was actually only used for wireless microphones. So this was sort of a nice thing that a lot of countries didn't have, which was a band that you could easily use wireless mics in that were that was the only service that was allowed in there. The downside to it was it's not that much spectrum, 36 megahertz there, So the wireless mic users in Japan didn't have access to the remainder of the UHF television band like we have in the US and other places. But again, that band has been, again, reallocated for government and telecom use, and the deadline to replace any A-band gear is March 31st of 2019. Again, Japan also had a pretty generous, from what I understand, government subsidy in place to help wireless mic users transition out of that band. So they now are opened up the lower UHF band. So they're sort of in the same situation we've always been in the US, which is you're sharing with television broadcast and just need to avoid that. The B band, which is a small range, an 800 megahertz that was for unlicensed users or just the general kind of public, I guess, remains unaffected and is still available. So again, to sum up the spectrum stuff, what should you do? Don't panic. This is not the end of the world. We will help you through it. Current owners of wireless mics in the auction bands really should consult with your manufacturer of choice or local regulatory agency for more information. Like I said, we have the incentive auction page on our website. If you go to the Shure FAQ and search for the FAQ ID 4108, that will bring up an FAQ that has links to many of the European Union agencies, so you can also consult there. Fairly useful stuff there. And again, when you're purchasing new wireless, of course, stay out of any bands that are auctioned. Shure doesn't have anything available for sale in any of those ranges anymore, but other manufacturers might, or dealers might have old stock on the shelves, so just make sure you're not buying stuff in the auction band.
Or if you're searching for used gear too, please keep in mind, just you're buyer beware.
Right. And then, as far as buying new wireless goes, you want to choose the most spectrally efficient wireless. And what that means is, given a small amount of available spectrum, how many wireless mics can I use in that small amount of spectrum? And consider alternative frequency bands where appropriate. I mentioned earlier, we have these unlicensed bands in 900 megahertz, 2.4 gigahertz VHF. These are not bad options depending on, again, back to the number one question, how many channels you need to use and what your specific application is. So those are a good option for certain users. Here's a spectrum analyzer shot of what we mean by spectral efficiency, and this is kind of an extreme example using the ULXD wireless, enabling a feature that's called high density mode, which allows you to use 47 channels of wireless in only 6 megahertz. Now, why do we choose 6 megahertz? That's, for reference, that's the television band width in the United States. So a TV channel, TV channel 42 or whatever it happens to be, occupies a 6 megahertz chunk of spectrum. And that's really the number we like to look at now when we talk about spectral efficiency. In fact, a lot of wireless mic manufacturers like to brag about how many wireless mics they can use total. If all spectrum was clear and there was no interfering television channels, you could use, 150 wireless microphones. Well, that's great, but how many people really need to use that many? And number two, how many people actually have all that spectrum available to you? In most urban locations, you do not have that much spectrum. Mm-hmm. So the other better way to look at it is like, if I only had one TV channel available to me, one 6 megahertz chunk, how many wireless mics can I use? And that's the spectral efficiency number we really care about. So some of our newer digital systems like ULXD and QLXD can do 17 versus, just for reference, ULX Professional, which was our best-selling analog wireless mic for a long, long time, can only do 6. So the numbers have gotten that's one of the ways that as a manufacturer we've tried to combat the spectrum crunch, is by making our wireless microphone systems as efficient as possible. Something that 20 years ago we didn't have to worry about because there was all kinds of spectrum available. Now we don't have that benefit.
I always like to say that it's like beachfront property. Everybody wants to live on the beach, and the beach has suddenly gotten a lot smaller. So you got to figure out how to put more people on the beach.
Right. So that number is an important one to look at when you're talking about how many channels do I need. A word about licensing. This pyramid kind of shows how wireless mic licensing works in the United States. And I don't want to belabor this point here because, like many other things, it varies by country. So you are probably worth, again, checking with the manufacturer or with your local regulatory agency to find out if a license is required, how much that license is, how long it's good for, et cetera, et cetera. In the United States, we have a scheme now where you can get a license, a Part 74 wireless microphone license, but it's not required. If you choose to operate without a license, you can, and you're just considered an unlicensed wireless microphone. Technically, the licensed users have a little bit higher status. What that actually means in practice isn't always clear. But as spectrum continues to get more crowded, it may behoove you to have a license. So it's worth just kind of thinking about checking into that. But in a lot of cases, it's not totally required that you have one. Now we're going to start looking at some of these other features we talked about. So one of the secondary features, one of the key elements to getting a wireless microphone system to operate successfully is making sure that it's on a clear frequency. Again, one of the number one phone calls we get here is, I bought this wireless mic and I'm getting tons of dropouts. What's wrong with it? And we'll say, well, have you tried, searching to make sure you're on a clear frequency? And the answer is no. How do I do that? Well, the good thing is that almost every system we make now, I believe I think actually all of them, have some ability for the receiver to scan and find a clear frequency for you. In fact, I'm going to play a little video here that actually kind of illustrates how that works. So you'll see this ULXD receiver is just doing something called a channel scan, which means it basically goes out and finds the best channel for you. You hit enter, and there you go. Now you just have to sync up that transmitter to the same frequency, and you're on a clear frequency. The receiver that is in the room or in the facility where you're going to be using the wireless microphone is always going to be best equipped to know what is the best frequency. Sometimes people will call us and say, tell me what frequency I should use for my wireless microphone. And we could, based on your zip code, do a search with the FCC information and tell you what we think is the best frequency. But the receiver that's actually in the room where you're using the wireless microphone is the best way to know that you're using a clear frequency. So that's a good feature to look for. The second feature that kind of ties in closely with that is something that we call infrared transmitter setup or transmitter sync. So once your receiver has identified a clear frequency, the transmitter needs to then be set to that same frequency. Most transmitters can be set manually. You can push some buttons on the transmitter to get it set to that same number. If a system is equipped with IR synchronization, usually there's just a sync button on the receiver that you push, and it sends an IR signal to the transmitter and says, hey, this is the frequency we're supposed to be on. So a lot of times when you have these two features hand in hand, it makes setup, two button pushes. Scan on the receiver, sync the transmitter to that frequency, and you're on a good frequency. And sometimes people will ask us, well, how often should I do this? Pretty much every time you change location. Whenever you're somewhere new, you can't just automatically assume the frequency I used last time is going to be a good one. And as you can see, if you have these quick setup features, it makes it pretty easy. So it's a good feature to look for. Kind of taking that to the next level is having networked receivers or transmitters if it's an in-ear monitor system. When you can network the receivers together, now they have the ability to talk to one another for even faster setup. When the receivers are networked, you can often have one receiver in the unit, in the system, do a scan and find clear frequencies for every networked receiver. On top of that, you get control and monitoring from a PC or Mac running, like in Shure's case, our wireless workbench software allows you to control and monitor and do advanced frequency coordination if your receiver is networkable. They're firmware upgradable to get additional features, which is also a nice thing. But let's take a look at how this networked scanning works. So in this case, we're using our QLXD system as an example. You can only see two receivers here, but it gets the point across because as you watch the video, you'll see, we scan on the first receiver, the network scan, we hit enter. And this receiver is going to go and find clear frequencies for everything. And now the other receiver is flashing network scan. So when I hit enter, now that top receiver has not only found a clear frequency for itself, but also for the receiver below it. And if we had a rack of 12 of these and they were all in the same frequency band, again, that one receiver would find clear frequencies for all of these units.
And the fun light show is just added icing on the cake.
Well, that's how you know it's doing something
That's
useful, right? Okay, getting into the digital versus analog debate. Why go digital? Well, for one thing, pretty soon it's going to be your only choice. Analog wireless microphone systems are going the way of the dinosaur, so you don't really have a lot of option there. In fact, we just recently discontinued our UHFR series, which was an analog system that for 12 years was the top of the line Pro Touring wireless microphone system, a great, great system, recently replaced by Axion Digital. So a digital system has now supplanted that one. So if you wanted to go analog and buy a Shure wireless microphone, you'd basically have to be looking at the BLX or SLX series, which is kind of an entry level and sort of a lower mid-tier wireless microphone system. And SLX is about 13 or 14 years old at this point. So again, kind of getting to be a bit of a dinosaur at this point. But, so why are we moving digital? Well, because if you want to build a wireless system these days, you almost have to go digital to get components, but there are some benefits there. Number one, fewer artifacts in your audio. Digital wireless microphone systems just sound much cleaner than even the best analog systems do. In fact, that was a challenge when we came out with our ULX digital system, which was priced a little bit more affordably than UHFR, but people started going with it just because they thought it sounded so much better because of the clean digital audio with no companding, greater dynamic range, all of that good stuff. You can also have better battery life. That's not inherent in any digital system, but depending on how it's designed, you can get better battery life and potentially higher channel count. Again, depending on the system. But in our UHF systems like ULXD and QLXD, the digital technology used in there has also allowed us to get higher channel count, better spectral efficiency, which, as we said earlier, is really important when we talk about the situation going forward. Now, one spec we don't like people to get hung up on is the range. Often people evaluate a wireless microphone system based on how far it can go. How far away can I walk before I'm going to get a dropout? But the one thing you need to ask yourself is, well, how far do you need to go?
Right.
Remember, the original point of a wireless microphone system was just so that you didn't have a cable to trip on, not so that you were able to, walk to the other side of the arena. Now, can some systems do that? Absolutely. And that's why we generally don't want people to get too hung up on that, because most of these professional wireless microphone systems, if you have line of sight on a clear frequency, you can get 300 feet of range. That's probably enough for most people. Now, you might have a specialized application where you need more, and that's fine. There are higher powered transmitters and high gain antennas and things you can add to try and increase that. But the other thing that is, I think, important to keep in mind is that the range is usually dictated then or limited by the RF noise floor in your environment, which is why it's so important to be on a clear frequency, which is where that scanning feature helps you out. So that's what this graphic here is basically showing, that, for a high tier system, if you're on a channel that has very low RF noise, you might be able to get 500 feet of range, right? But if you're sitting right on top of a DTV channel, like here, like it looks like channel 25 might be on the air, if you tune your wireless mic to the same channel as an on-air broadcast station, you might get 10 feet of range. So really, it's all about, again, it all comes down to signal-to-noise ratio in the RF realm, right? The better your signal-to-noise ratio, the better the range of the system. So again, it could be important depending on your application, but that probably shouldn't be the number one thing you go for when choosing a wireless mic. Batteries is another issue. How many of you have seen this situation before, right? Batteries can get expensive. They're not environmentally friendly, but they are required in a portable device that you don't want a wire tied to, right? You've got to deal with them. Most of the time, traditionally, we would always recommend going with good old alkaline batteries, Duracell, Energizer, sort of the name brands that and that would get you the longest continuous run time. People have often asked us over the years about using rechargeable batteries. Back in the 9-volt days, it wasn't necessarily a good option because 9-volt rechargeable batteries, especially NiCads, were horrible. They never even actually got to 9 volts when they were fully charged, and their current capacity was so low that they die within a couple of hours. So they weren't always the most reliable option. In the AA world, some of the nickel metal hydride solutions, if they had a high enough current capacity, could do a little bit better, but they would never quite match up to that alkaline, which, depending on your application, may or may not have been okay. So there's some new lithium polymer batteries out there for 9 volts. If you're still using a wireless mic that uses a 9 volt, those are options again, or a nickel metal hydride for AA. If you are using rechargeable batteries, the suggestion is to have multiples, right? Yeah. One that's in use, one that's ready to go, and one being charged, because you just never know, right? Someone could forget to charge the batteries, who knows? So you always want to have backups. Some manufacturers, Shure included, are now producing their own proprietary rechargeable solutions. We are using lithium ion technology, which is a medical grade cell with really long runtime, no memory effect. And the best part is the intelligent battery metrics you can get off of it. So you'll notice at the bottom there, the receiver screenshot is showing you battery remaining runtime in hours and minutes, which is really super accurate. And that you don't get that with a standard alkaline battery. There's no way to pull that information, so you just get the bars, kind of an estimate: 4 bars, 3 bars, 2 bars. How do I know how much time is left? I don't know. Better just change the battery. You end up wasting a lot of batteries that way. But with these better battery metrics on some of these rechargeable options, you can really keep better track of what's going on. Encryption is a feature that allows secure transmission. Again, in most performance applications, we probably don't care too much about this unless you're worried about someone bringing a receiver
Don't want
in.
them to hear my new song.
Right, and bootlegging your concert based off your wireless mic. It actually has happened, but in a lot of corporate applications, particularly in the financial world or government applications where they're really concerned about things being eavesdropped on, encryption is a nice feature where the digital audio is actually encrypted with a unique key, and no other receiver in the world can demodulate the audio from that signal unless it shares that unique encryption key that is paired up during the IR sync process. So that is a really nice feature that, again, not necessarily usable for everyone, but in certain applications, you definitely can make use of it. I want to talk a little bit about antennas here before we wrap up and get into Q&A. What do I need to know about antennas? Well, how many systems are you using? Are you using more than 3 systems? Maybe we need to talk about antenna distribution. Are the receivers in a closet somewhere, not in the same room where you're actually using the wireless mics? Then maybe we need to talk about remote antennas. Do you need really long range operation? Then maybe we need to think about higher gain antennas. These are all things that come into play, and all things that require a receiver that has detachable antennas. Again, an unfortunate phone call that we get sometimes is someone may have bought a BLX receiver, which is nothing wrong with it. It's a great receiver, but it has internal antennas that cannot be removed. And then it turns out they want to install these receivers in a metal equipment rack in a closet. Mm-hmm. Well, now the antennas are inside of a metal rack, which is a definite no-no. And you have no option to remote mount them because you bought a system that doesn't have detachable antennas. So again, this is why it's really important to think through all of these things, like where are the receivers actually going to be located, what kind of rack are they going to be in, and then you can think more about, maybe I should get a system with detachable antennas. Or if you're going to rack mount multiple receivers, again, antenna distribution, which is the first thing we talk about here, is what allows multiple receivers to share a common set of antennas, because this setup right here where you got antennas kind of cascaded really close to each other, not the best idea in the world. These antennas will actually interact and disrupt their patterns, giving you unpredictable coverage, could cause some receiver interactions. It's generally not a good idea. So you go with an antenna distro, which is a rack mount unit that takes the signal from one pair of antennas and splits it with makeup gain to additional receivers. In this case, this unit can do 4 or 5 receivers, and these can be cascaded together for larger systems. But again, now you've got just one pair of antennas to deal with instead of all of those other antennas crammed right next to each other, which, like I said, can negatively affect performance. So antenna distribution ends up being one of those things. It's one of those accessory items where people go, do I really need that? Really? Mm-hmm. That's another, however, $200, $300, $400, whatever it costs. It's like, well, do you need it? Will the systems function without it? Yeah. Will they work their best? Maybe not. So if you really want it to work, and again, anytime you're using 3 or more rack-mounted receivers, it's probably a good idea to get an antenna distribution unit. As far as other antenna options go, let's assume you're remote mounting them away from the receivers. All of these different options exist for many different reasons. The half-wave Omni that's shown in the lower left corner is what's included with most professional wireless mic systems, and this antenna can be remote mounted if necessary. But maybe you are putting the system in a room where they don't want to see the antennas, they don't like how they look, you go directly above that for the omnidirectional wall mount antenna. It just looks like a little Wi-Fi access point, and that can often blend into a conference room much more effectively. If you need long-range application, that's where the active or passive directional or even the helical antenna for extreme applications come into play. Those antennas have forward gain associated with them. We have a whole webinar on this topic as well. If you'd like to learn more about its correct antenna placement and antenna configuration, I suggest you take a look at that webinar.
Shure.com/training.
Thank you.
You're welcome.
And then there's also things like inline amplifiers and bias tees, and these are all things that, again, may be necessary for more sophisticated high channel count systems. So to recap, steps to choosing a wireless. Number 1, take inventory of all your wireless audio equipment that you currently have, as well as what your future needs are, so you have a total channel count. Select the microphone that you need for your application, whether it's handheld, head-worn, lavalier, whatever it happens to be. Note equipment locations and potential antenna locations. This is if you're going to be putting them somewhere other than directly in line of sight to where you'll be using the microphones. So that's really it. I mean, if you take all of those things into consideration, that will get your basic needs sorted out. As I say, number 1, always think about how many channels you need. And then once you've got that figured out, then you can think about, do I need to be rack mount? Do I need it to network? Do I need scanning? What are all those other things? That's when those things start to come into play. In fact, let's take a look here. I'll just show you kind of a way you can see this. This is some additional resources that we have. A great educational booklet that's called Introduction to Wireless Microphones. The Wireless Frequency Finder on Shure.com can be a good sort of planning tool for figuring out which frequency ranges are the best ones for your area. You just put in your zip code and it will tell you. The Wireless Accessory Wizard kind of shows some of those antenna configuration issues we were talking about. And I just want to show you this comparison chart that's on the Shure website, just because it gives you, different wireless mic options for handhelds on the first page, but really the second page is a little outdated. We need to add some systems to it here. It's not totally complete, but it goes on for a couple of pages here. But the reason I want to point this out is because it shows you compatible systems per band, right? This is a quick way to gather that number, okay? How many wireless mics do I need to do? And then you can start to see where you need to be, right? Up to 5, up to 12, up to 8. Okay, so we're in entry level land here. Let's scroll down a little bit. Up to 12, up to 20, up to 60, up to 60, up to 40, up to 72, right? So that's the kind of information, that's those numbers you sort of want to be looking at there for wireless microphones. And again, that information is going to vary by system, by manufacturer, but it is out there. So that was a lot of information in there, but we'll be happy to spend the remaining time answering any questions you might have.
All right, we've got a couple here, and if you've got them, we've got some time, so feel free to type those in, and we'll get through as many as we can. All right, question number 1. When needing 30 mics for a theater production, what limitations can I expect with mixing systems, like PGXD, SLX, over GLXD, ULX, or would I need to stay with one system?
So there's a couple of things wrapped up in that question. It's actually a great question to address that issue with, because as I mentioned earlier, you typically want to go with the lowest common denominator, right? But that's also assuming that all the systems are in the same frequency band. So if they were all in the UHF television band, then you would want a system that can handle at least 30 wireless microphones, if not more, to give you a little flexibility, which in the current lineup of things from Shure would be like a QLXD system or above. Now, but you mentioned a couple interesting things in there, like PGXD and GLXD, right? Those are in different frequency bands. PGXD is in the unlicensed 900 megahertz band. GLXD is in the 2.4 gigahertz unlicensed band. And those two bands are far enough away from the UHF television band that there's really not going to be any interaction there. So in that case, you can kind of stack them up. You can sort of max out each one of those different ranges and then use however many you need to in the UHF band unaffected by that. Now, a downside to that is a couple of things. Number one, with a large wireless microphone setup, you probably want to rack mount things. GLXD. Well, I take that back. There is a rack mount version of GLXD now called GLXD Advanced. PGXD is not rack mountable. The second thing is now you end up with 3 different wireless mic systems that have transmitters that look a little different. They may take different batteries. The operation of them is a little bit different. So it's often for the sound engineers that are going to be called upon to run this system. Now they have to kind of learn how 3 different systems work. Whereas if it was all QLXD and they were networked together, operation becomes much more streamlined and simple, and there's monitoring and all of those kinds of things. So while in theory it's possible to do what you're suggesting from an RF perspective, it would work. There's some other logistical considerations you might want to think about there.
All right, great. Speaking of the 2.4 gigahertz band, next question. For what purposes or scenarios would the 2.4 gigahertz systems be recommended? And what's the maximum number of systems recommended in 2.4 gigahertz?
So my answer to that, I would say, is low channel count. And by low, I mean 4 or 5 maybe if you're using the regular GLXD system. If you're using GLXD Advanced, 8 to 10. And shorter range applications. That because of the higher just general noise floor in 2.4 gigahertz and also the additional losses that there are with shorter wavelengths at higher frequencies, the range of those systems typically isn't quite as great as you get with the, again, more traditional UHF system. So again, I think of, again, bands that only have a couple of channels of wireless and they keep the wireless receivers close by on stage. Those sorts of applications, small houses of worship that only need a handful of wireless and again, keep the range relatively short. That's where you would think about those bands.
Okay. This next question, hopefully you can understand because it's a little bit above my head. Thoughts on band pass or low pass inline antenna filters? Filters when antennas are in the audience area, aka the seat of cell phones. And what is the availability of filters?
So yeah, you're referring to a couple different types of filters you can put in line between your antennas and the receivers that are meant to limit what the receivers are seeing in terms of external RF. And there are some broader filters that can be, 24 megahertz or so. There are some types of cavity filters that can get as narrow as 6 megahertz, so down to 1 TV channel. Those get used in very high-end broadcast applications and when we're talking about the Today Show being outdoors in middle of Manhattan or whatever, where the RF noise is very high. So they're not the kind of things that are necessarily affordable or readily available, but used properly, yeah, they can certainly work. I mean, the idea is that if you can limit the exposure that the receiver has to external RF signals, that's only going to help the performance of the system. The thing to keep in mind, again, is a lot of these wireless mic receivers are very wide tuning range devices now. The Axion digital receivers from Shure, have tuned the entire remaining UHF band from 470 to 616 megahertz. So if you wanted to get into using those types of filters to protect the receivers, you'd actually have to put them on the outputs of the antenna distro and make sure that they're lined up with the appropriate receivers that are just meant to receive within that certain limited range. So, I certainly don't want to say they're not a good idea. They're a great idea, but they require a whole host of planning considerations to make sure that they're being used appropriately. And again, often not required unless you're talking about really, really high channel counts in really, really crowded RF environments. For most general applications, could be useful, but probably not needed.
Okay, great. Okay, what are the major differences between QLXD and ULXD?
Getting product specific. Okay, the major differences are that high density mode we talked about earlier with ULXD, where I showed the graphic where it looked like you could use 47 wireless mics within only a 6 megahertz DV channel with just a slight trade-off in range. That's a ULXD specific feature that QLXD doesn't have. Also, ULXD has dual and quad receiver options with Dante digital audio networking. So if that's something you're interested in, you would have to go to the to the ULXD series. And the seems like more of a minor thing, but the display on the receiver is a little bit more, what the word for it is, user friendly maybe. The QLXD is an icon based display, so sometimes it's a limited range of characters, and sometimes you have to really stare at it for a few minutes and figure out what it is that I'm trying to get to move through the menus. Whereas ULXD, again, if you do a lot of menu navigation, it's a little easier to see its way around. Otherwise, they're very similar. The channel count in standard mode, the density is pretty much the same. The audio quality is the same. The RF performance is the same. And they use both are compatible with the SB900 rechargeable, and they're networkable. So, and a lot of times, if you need to save a few dollars, QLXD is a great way to go. But if some of those other features are important to you, like high density and Dante, then you would go ULXD.
Great. All right. Could you use an active antenna on an IEM transmitter? Knowing that there is no DC provided by the IEM or combiner, having external bias T, would it be possible?
Well, legally, it's not allowed. The transmitters in the in-ear monitor system, right? Well, any transmitter is got a power limit that is specified or through the FCC type approval process. And this is talking U.S., but I'm sure it's the same, but regulatory bodies in many other countries, right? So you're not allowed to transmit at levels beyond what the FCC approval is there. So by putting an active antenna on there, you have now taken it out of regulatory spec. So we don't really allow for that. Not to mention the amplifier, even if you could power it up, is a one-way amplifier. So you correctly identify that, yeah, there's no voltage there to power the amplifier, but also the amplifier only allows it to work as a receive antenna. It won't boost the signal in the other direction. Now, you could use a passive directional antenna, like our PA805 can be attached to a transmitter, or even a helical antenna can be attached to an in-ear monitor transmitter antenna. And those things, because it's passive gain, it's okay. That doesn't take it out of any FCC regulation if you want to put a passive antenna on there.
All right. Okay, how many ULXD4 quads can we have as for a daisy chain antenna system?
Okay, so for those of you who aren't familiar with the ULXD dual and quad receivers, there is an antenna pass-through or cascade output, which allows you to attach antennas, A and B antennas, to the first receiver in the chain, and then loop those out to another receiver, another dual or another quad. And that's the limitation. You can go to one additional unit. So you can put two quads together, or a dual and a quad, or two duals, but you can't go beyond that. If you have more than that, then you need to be looking into external antenna distribution.
Okay. How to deal with applications where others, like press, show up with wireless systems minutes before a conference starts?
Well, that depends. How strong of a personality are you? In a perfect world, well, okay, so I'm assuming we're talking about an application where there's lots of wireless being used, right? Because that's generally where this gets to be a consideration, right? And if you've done things right, you've used software like Wireless Workbench to come up with a list of compatible frequencies, and everybody that you know about is already using those compatible frequencies. When someone shows up with a rogue wireless mic, if you see them come in and you're aware that they're about to fire up, you really need to have a conversation. You need to corner them and say, look, I need to give you a frequency. Tell me what you have. And then you go back to your carefully planned coordination and you add their system to your inventory and you give them a frequency. If you're not able to do that, then, well, this is why, again, in that application, it pays to have an RF tech that's kind of monitoring the spectrum and looking for these things so that you can tell when rogue transmitters fire up. It's a coordination exercise that needs to be constantly monitored. And at applications like the Super Bowl, that's one of the jobs of the RF coordinator, is to be constantly on the lookout using scanning devices for these rogue transmitters and actually sussing them out and making them shut down if they're not authorized to be on there, or giving them saying, hey, you have to use this frequency so that you don't cause other problems.
Okay. An exercise in RF and diplomacy.
And diplomacy, yeah, that's certainly a part of it.
All right. Are wireless body pack transmitters application specific? I.e., can you only use an instrument body pack transmitter for an instrument, or can you use it for a lavalier? Do you have to have a specific body pack for that specific output source?
I don't want to speak for all manufacturers, but within the Shure line, the body packs are designed to accept an instrument or a microphone. And we have the cabling options to accept either one. So there really is no difference there.
Great. Okay. I have a system of 16 QLXD 24/85s and 12 wireless clear comms in Richmond, at the Richmond High School, I think in California. I was planning on using the G channel. How many more receivers can I add? This is like a math problem.
Well, and this is very application specific, so I don't know that I can answer that off the top of my head. We'd probably have to consult our frequency finder and see what spectrum is available in your area, and do a coordination for you. So this is the plug for Shure Applications Engineering. You
Correct.
might consider sending that request to support@shure.com, and one of our applications engineers can assist you with crunching those numbers and give you a solution.
We have a whole team, Gino's team, that is here to answer those kinds of questions. So, support@shure.com is a great place to send an email if you have a question or if you need help with something more complicated like this. Also, our FAQ is very robust. So if you just have a very simple question that's maybe not specific to your application, it's always a good idea to go to shure.com/FAQ. We've got, I think, over 2,000, maybe almost 3,000 questions in that database. And you can always type in, your question or some keywords to that question, and you'll be surprised how much information is there. We just have a great team here on site. So actually, that pretty much wraps up our time. We got through most of the questions. If we didn't get to your question, please feel free to send an email address to support@shure.com, and that great team can answer almost any question you've got. We want to thank you so much for joining us. We hope you enjoyed it as much as we did, and we hope to see you next time.